In this lecture, we're going to see how the const keyword can be used with references. And again, the idea is to set up an alias to a variable and make it const so that we can't go through it to modify the original variable. This is the syntax we use to set up a non-const reference that we have seen so far. So for example, we can say int age, put in a value 27 in this case, and set up a reference to age and initialize that with the age variable. Once we do this, ref age can be used to modify this age variable here and whatever is inside. For example, we can go through ref age to increment the age, and if we print the age now, we should get a 28 printed out because this reference is going to change these two things at the same time. Or another way to say this, these two things, age and ref age, are referencing the same memory in your computer. So if you change one, the other is going to pick up the change. We can also set up a const reference, and the syntax is ridiculously easy. You say const int reference like this, and your reference is suddenly const, and you can't go through it to modify the original variable. If you need something like this in your application, this is how you do it. You can also duplicate the behavior with const references with pointers, and for that we can use a construct like const int pointer const. This is going to set up a const pointer to const, which we can't use to modify the value that we are pointing to, but it can't also be used to point to something else. So this is going to simulate the behavior we have with references. And you can do that if you want. And please note that we have no such thing as const int reference const. This is going to give you a compiler error because we have no such concept in C++. And my head is hurting right now trying to think about what this would even mean. And another thing I want to make clear before we head over to Visual Studio Code and play with us is that the const keyword is going to apply to the variable name that you apply it to. For example, here we have const reference age, which is going to be a const reference, but this doesn't mean that the age variable here has to be const. Okay, it can be const or it may not be const, but the const here applies to this variable name, const ref age, and we can't go through this variable name and modify the age. If you're trying to do that, we're going to get a compiler error. Now we can head over to Visual Studio Code and play with us. Here we are in our working directory. The current project is reference and const. We're going to grab our template files pretty quick. Let's do that. And we're going to put them in place. And we are going to open this in Visual Studio Code. We are going to review the references we have seen so far in this little example here. We have the age variable. It has a 27 inside and it is an int. And we have a reference to it. And this reference is not const. So we can go through this reference, modify the age. And if we do that, this is going to work. And if we print the age here, we're going to see that it has turned into a 28. And we can try and print this through the terminal so that you can see this for yourself. So let's run the task to build with GCC. We are going to clear and run rooster. And if we do that, you're going to see age is 27, now it is 28, and we have successfully modified data through our reference here. But if we change this reference to be const, we won't be able to do that anymore. So let's try and make it a const reference. If we do that, we're going to get a compiler error if we try to do something like this, because this is now a const reference. We're going to go through it to modify our data here, and we're going to get a compiler error. Here we have Visual Studio Code complaining here, but if we ignore that and go through the compiler, we're going to see that we get the same compiler error. We can't implement a read-only reference, which is this ref age here. So this is what a const reference really is. You can't go through it to modify the data that is being referenced. And another thing I want you to really understand is that this const keyword here has nothing to do with the original variable. This is a const reference. We can't go through it to modify the age variable, but this doesn't matter if age is either const or not const. The constness here applies to this variable name here. So this const age may be const. If it's const, it's going to work equally well, and we're going to still get a compiler error here. If it's not const, it's going to be the same. The const we have on our reference applies to this reference variable name here. This is what I want you to understand. Okay, this is what a const reference really is. Another thing we want you to see is that we can simulate the same behavior with pointers. So let's set up a const pointer to const on this edge here, and we're going to see that we can have the same behavior. But for that, we're going to have to comment this out because we don't want noise output. And we're going to go on top here and comment this out and say what we are intending to do. We can say that we are simulating reference behavior with pointers. And the way we're going to do that, we're going to say const int pointer const, and we're going to say ph, and we're going to initialize this with our age variable, or the address of our age, to be super clear. Okay, so we have our pointer set up. Let's try and go through it and modify the age. Let's see what happens. The reference, because this is a pointer, and we're going to say page and say plus plus, or even change this to another age, let's say 45. And if we do this, we're going to get the same compiler error. So if we build this, let's clear here, clear, not clear, and build again, we're going to get another compiler error saying that we can't modify something that is read-only, assignment of read-only location. This pointer can't be used to modify the data in this age location here. So this is the same behavior with references. Because a reference by default can't be made to point somewhere else, we had to make this pointer also a const pointer, preventing us from making it point to other locations. So this is how you can simulate references with pointers. And this is really all we set out to do in this lecture. I hope you found it interesting. The main idea was to let you know how you can work with const references. And once you have a const reference, you can't go through it to modify the original data. If you do that, you're going to get a compiler error. We are going to stop here in this lecture. The next one, we're going to see how we can make use of references and do some cool things in our range-based for loops. Go ahead and finish up here and meet me there.